This is Psychology 7540, Statistics, and today I'm going to talk about descriptive statistics. Now there are two broad areas of statistics, descriptive and inferential. Inferential deals with probability and making inferences about a population from a sample. The purpose of descriptive statistics is just to describe without inferring or implying anything about a larger population. So now there are two basic descriptive types of measures. There are measures of central tendency and measures of dispersion. So let's say we have a classroom with 100 students and we get the age of each of those 100 students. Now a measure of central tendency is going to give us one number that best summarizes those 100 ages. So let's say our one number is 35. So that's right at the peak of this curve. Our most characteristic age is 35. So we could do that by taking the average, add up all the ages, divide by the number of ages, and that's what statisticians call the mean. Now that only tells us part of the story, because in one classroom you might have 100 or 50 people that are age 70 and 50 newborns. Well, that's a very different picture from having a classroom where you have 100 people that are exactly 35 years old. Or you might have anything in between, where you have them, some people are 30, some are 40, some are 50, where it's spread out. So you need another measure to really describe the distribution. And that's a measure of dispersion, how spread out your scores are. Now there's three typically used measures of central tendency. There's the mean. So that's used if you have what's called interval or ratio data. So scores, scales, measures, things like weight, height, IQ score, those are all interval level data. So you'd use the mean for that. The median is used when you have ordinal data. Those are things such as ranks, and it's also used when you have skewed data. That's data that doesn't follow the typical normal distribution, where it has a long tail to it. So a median is usually better for that. A mode can be used, and it's the only type of measure of central tendency that can be used with nominal level data. Nominal level data is categorical. So gender is nominal, what state you were born in as nominal. So if you have 100 people and you ask what state were you born in, well, you can't take an average of that. You can't find the median. All you can do is to say what the most common state is. So that's the mode. So looking at this picture, we have a classroom with 1, 2, 3, 4, 5 boys and 2 girls. So the modal gender in that classroom is male. There are more boys than girls. Now, I mentioned that the median can be used with skewed data. So let's look at this boardroom. We have the chairman of the board. His annual salary is $2.4 million. And then we have the board members. This one makes $100,000. That's his right-hand man. Then we have the other salaries, $42,000, $24,000, $75K, and $65K. Now, it would not make much sense to take the average of those, because it would look like the average salary is a few $100,000 a year. And really, there's only one person in this room, the chairman of the board, who makes over $100,000. So it makes more sense to take the median. The way you take the median is you line up all the salaries in order, and then you take the one in the middle. So the median salary in this room is $65,000. Now the mean is what people most commonly think of as average. You add up all the scores, and you divide by the number of scores. So let's look at the ages of the children in this classroom. 8, 10, 9, 11, 12, 8, and 12. So we have 7 children in the classroom. We add up all their ages, and we get 70 as the total. We divide by the number of ages, 7, and so the average or mean age is 10. Now let's look at this formula here. This is the most basic statistical formula, and it introduces you to some of the concepts in statistical formulas. Like all math formulas, they look very scary and intimidating until you understand what they mean, and then they're fairly simple. So this funny looking E is the Greek letter sigma. It's a capital sigma, and it simply means take the sum of. This X refers to all of the scores, all of the ages in this case, and the N is always used to refer to the number of scores. So this formula just says take the sum of all the scores and divide by the number of scores, and that equals X bar, which is the symbol that we use for the sample mean. Now, measures of dispersion, the two most important measures that you need to know about are the variance and the standard deviation. The variance is the average of the squared differences of scores from the mean. So let's look at the formula again. Variance is symbolized as S squared. Take the sum of each score minus the mean, square that difference, add up all of the squared differences, and divide by the number of differences. So that's S squared in the variance, and then to get the standard deviation, you take the square root of the variance. The standard deviation is back in the original unit. So if we go back to our classroom with 100 people, we say the mean age is 35, and the standard deviation is 5. That 5 refers to 5 years. So you could say the mean is 35 years, the standard deviation is 5 years. Sometimes in these formulas you'll see a denominator of n minus 1 instead of n. That's an adjustment factor. This is a little bit off for estimating the population variance and standard deviation. So the sample standard deviation and variance have a denominator of n. You need to adjust it a little bit. It needs to be slightly bigger in order to estimate the variance and the standard deviation of the population that these samples were drawn from. Now let's look at the step-by-step calculations of getting the variance and the standard deviation. Let's say we have these 4 children, Bill, Mary, Bob, and Carmen. Bill is 8 years old, Mary's 10, Bob is 12, and Carmen is 10. We figure their average age, so we add up those 4 ages, we get 40, divide 40 by 4, and we get the mean age is 10. Then for each student, we'll figure the difference between their age and the mean age. So 8 minus 10 is minus 2, 10 minus 10 is 0, 12 minus 10 is 2, 10 minus 10 is 0. Then for each of those differences, we square it. We get 4, 0, 4, and 0. We add up all of those squared differences. 4 plus 0 plus 4 plus 0 is 8. We divide by the number of scores, the number of squared differences. 8 divided by 4 is 2. So our S squared, our variance is 2. Our standard deviation is the square root of that, which is 1.4. So let's look at how we'd apply that to our normal curve. Now a normal curve is how large populations generally distribute themselves. If you took the age of everyone in the United States and graphed it out, it would look very much like this bell-shaped curve. Now for our particular group, we found that the mean is 10. So this peak of the curve is 10 years old, and our standard deviation was 1.4. So that means this point on the curve is 11.4 years. This point on the curve is 8.6 years. And the characteristics of a normal curve are very well defined. So we know that between -1 standard deviation and +1 standard deviation, 68% of the population lies within those parameters. So this group of children is representative of a population where 68%, about 2 out of 3 kids, has an age between 8.6 and 11.4. So that concludes the segment on descriptive statistics.